Okay, here we go with a question. This is about the wave model. We're looking at, firstly, the nature of waves, and then we're going to be asking to calculate the average speed of a particle in this wave. As ever, please take a second to try the question, and when you are happy to watch on, please look at my answer. Okay, so we're given some information. We're told that the transverse wave has a period of 20 milliseconds and it's traveling through a medium. We're shown the variation of particle displacement with distance. Okay, we're then asked to know the average speed and the direction of the particle. So in this case, I'm going to start with this one because it's one of these questions where you're just going to start ruling out answers. This one, we're going to look first at our information given at the top. It's transverse. So we should know that a transverse wave is one in which the displacement, the variation, the disturbance, however you want to call it, is perpendicular to the direction of motion of the wave, or direction of energy transfer. And so therefore, we're going to get rid of two of the answers. We're going to get rid of those two parallels. That would define a longitudinal wave, and so therefore we can get rid of it here. Just be careful when you're looking at these questions. If they specify transverse, they've often done it for a reason. It's because they want you to demonstrate that you know that transverse wave has a perpendicular disturbance. Now the next bit, and this is where students get tripped up, is to calculate the average speed of the particle. Now notice here, we are not asking for the speed of the wave, and that is a part where students will make mistakes here. We want to know the speed of the particle. Now, to do this, we're going to think about a particle. Let's imagine this guy at the top, and we're going to think about how fast it travels on average during one cycle. Now, you'll notice here we've got a displacement of 4. Okay, we're going to use this very simple equation v equal d over t. Speed is distance over time. During one cycle, our particle at the top is going to travel down to the middle, to the bottom, back to the middle, and back up again. Every particle is going to follow that journey. So what you've noticed there is I've done 4 amplitudes. Yeah, the amplitude of this wave is 4 centimeters. So we're going to do 4 amplitudes, and we're going to divide it by the time. The time is just the period, which we're told in the question, 20 milliseconds. And at this point, it's a question of making sure we've got our numbers in correctly. We're going to do 4 times the amplitude, 4 times 4 times 10 to the minus 2. Divided by 20 milliseconds, that's our 20 times 10 to the minus 3, which is going to come up with 8, which is why the answer here is B. Now again, like I've said, I think the issue here comes with the fact that some students don't pick up on the fact that we're talking here about speed of the particle rather than speed of the wave. Some students here would possibly start thinking about speed equals frequency times wavelength, and they'd calculate the frequency, use the wavelength from this. That's the wrong approach. We're asking about the speed of the particle, not the wave.